All right, everybody. New question, question 41. Alex wanted to light up three bedrooms for three guests in his house. He has the following components to construct the circuit, but he does not need to use all the components. All right, so this is a electrical circuit question. So he has three light bulbs, three batteries, more than three switches, unlimited lengths of wires. So you're supposed to draw a circuit diagram using the circuit symbols to show the best arrangement that he could make to light up the bedrooms in the brightest way. Alright, so there's a lot of clues there. So the first one is the three batteries. So if you want it to be the brightest, you need to use all three batteries. I'm going to use uh, all the three batteries. Alright, but to draw the battery, of course, we know it's two lines, right? One short line, one line shorter than the other. Right, so this is the battery that I've drawn, right, using even in the exam questions when I draw batteries, this is the technique I'll use. Okay, so I'm also showing you how to use how I draw the batteries. All right, so uh, the batteries, uh, if you want to use the bulb, if you want to light up the bulb as the brightest, you need to use all three batteries. So here we have all three batteries in series, right? One after the other. Right now, after you have the three batteries, then you have the three bulbs. Okay, so the three bulbs, as we know, bulbs are drawn like that, right? There's one circle, and then it looks with an X in the middle. It looks like the X-Men symbol. I keep telling people this. Right, so it's very easy uh, to draw the bulb, get a symbol for the bulb. Now we all know we've done this many times, that the bulb is actually, what do you call that? The bulb is actually uh, uh, best lighted if it's just three bulbs into three bulbs and what do you call this? Three bulbs and sorry, one bulb with all three batteries connected to it. So this is, I think, is the brightest. If you want your bulb to light up the brightest, it'll be like that. Okay, so you have one here, and then you have another which is on the other side, right, like that. Oh, sorry. Then you have another on the other side which is like that, right, and then like this. Okay, but of course you uh, cannot draw it like this. You need to draw it properly, right? So something like that. Okay, and then you have one here, two here, right? Like that lah. Okay, so we have like this. Something's wrong. Just gonna delete things in between. Okay, so something like that. One, two, and three. Alright, and then of course the wires have to meet. Alright, so you have here one battery, two battery, three battery using a bulb. Right? Okay, so here we have three batteries lighting a bulb. This would cause this bulb to be the brightest. Right? This would cause this bulb to be the brightest. Okay, I'm going to bring the bulb nearer to the battery so that ta-da. Alright, okay. So if you have three bulbs, if you want to add another bulb and you want the other bulb to be of the same brightness of this bulb, of course, you add it in parallel, right? So it's like that one, and if you add it like this, you have two. So both bulbs now will be as bright, and the first bulb will be the second. The second bulb will be as bright as the first bulb without compromising its brightness. Okay, and likewise, if you want to add any other number of bulbs and all the bulbs with equal number of brightness, not affecting the first and second arrangement, it will be like that. So if I would like to just demonstrate with you using numbers, because some of you can think there are three units here. Okay, three units of brightness. Okay, three units. I'm going to write three units of brightness here. If you have three units of batteries here, then your bulb will be three units here also, three units of brightness, because three batteries supplying one bulb at first is three units. Okay, but the good thing about it being in parallel is that if you put the second bulb, right, it doesn't change anything. If you put the second bulb, it will still be 3 units. Okay, sorry, second bulb, it will still be, I'm going to delete this part first. Okay, now second bulb will still be 3 units. Alright, okay, and then the third bulb will still be 3 units. Alright, second bulb will be still 3 units. Okay, I'm going to delete this. Okay, so as you can see, this is the brightest lah. Okay, now why is it that this is the best? It's because each bulb is deriving its electrical energy directly from the batteries, right? So you can see that the batteries is directly supplying this bulb, the first bulb, and then the batteries directly supplying the second bulb, and then the batteries are supplying directly. So all three bulbs will not be affected by each other. They will all be acting independently and all are getting the full units that the battery has to offer. Alright, so I'm gonna just remove the unit because you don't have to do that now. But the problem with this is that the bulbs are permanently on. So if you want the batteries to the if you want Alex to have uh, individual control of each bulb, you need to add something else, right? You need to add something else, right? You need to make sure that first that the bulbs are not what do you call that? Not on first, right? And then after that, you're supposed to have a battery. You're supposed to have a switch, right? So you have a switch like that. Okay, you have one that is here, one is like that. So the switch is normally open. I'm gonna draw the switch. The switch can be closed, can be open, can be closed, can be open. But this time, we want it to be open so that the guests have the power to control the switch. So you have one switch here. Okay, if you have one switch here, that means one switch to control all the three switches, which we don't want, right? Because some people, you want the switch to be, controlled by the guest in this room, room one, right? Oh, sorry. Then you want so I have to make copies of the switches first. Okay, 1, 2, and 3. So the first switch goes here, right? And then the second switch, okay, so second switch goes here, right? And then the third switch goes here, right? So now you have all the guests able to control the light in their own rooms. Alright, and of course you would like to reconnect this back so that there's power supplying to the rooms, right, all the time. Okay, so this is the best arrangement he could make. Alright, now this is different if you do it in series. If you do in series, then it will not be like that. So I'm gonna also show you. Oh, sorry, I'm also gonna show you how it will look like if it's in series, right? If it's in series, then it's gonna be something like this, right? Uh, it's gonna be something like that. I'm gonna delete all this. Okay, I'm gonna delete all this. Alright, so this is you have the three bulbs in series. The problem with the one in series is that if you first of all this bulb, the second bulb, will not be able to get its power directly from the battery, but instead getting the power from the first bulb, and then the third bulb getting its power from the uh, first and second. And then what this would cause is that it would be dependent on so it's not an independent arrangement, it will be a dependent arrangement. So you have something like that, right? And then you have a line in between, and of course you can't put the switches anywhere. If you put the switches you can only put one of the switch here. So let's say I use the switch here. Okay, if you put the switches here, then you have one switch to control them all, right? Which is not a good thing because that means the individual guests in the individual room cannot control their own light. Can you imagine if your dad switches on his light in his room, then the whole house is on, brightly lit, right? And if your mom or dad switches the lights in the master bedroom, for example, or the living room, the entire house it's in darkness. So this is not a good uh, not a good arrangement, right? So this is not the answer. I'm just showing you the answer is in the box. This one is just for you to know. If you compare, this is better and this is not as good. Okay. So state one advantage of the arrangement you have drawn in part A. Right. So if you draw the advantage, sorry, if you have drawn this, if you have drawn this and you're imagining this, you would know immediately. Sorry, there's a B. Okay. What would happen if an additional battery is added? So if there's an additional battery, the fourth battery that is added here, you can have the brighter bulbs. All right. So the bulbs, you can see the bulbs will be brighter because now you have 4 units, isn't it? Let's stop. You have 4 units supplying 4 units of electricity to all 3 bulbs, right? So the bulbs will definitely be brighter. So state one advantage. Now, so there are several advantages that you can write. I'm going to write all 3 so that you can learn. Okay, the first advantage is that the bulbs compared to the bulbs will also be brighter, right? The bulbs will be brighter, right? I've explained to you. If you use the one here on the left, this circuit left, each bulb is taking its electrical energy from the batteries directly, all right? And therefore, each bulb will be 3 units bright, all right? Whereas over here, if you arrange it this way, each bulb is taking energy, sorry, only the first bulb is taking the energy directly, whereas second and third is not. And therefore, all the 3 bulbs will be sharing the 3 units. So here you have 1 unit each, right? So that's why the bulb that you have chosen for A will be brighter than the bulbs in series. Right now, the second reason is because if you use the one in series, if one bulb fuses, then all bulbs will not light up. Yes or no? Because the circuit will be broken. But here, if the one on the left, in parallel, one bulb fuses, the other bulbs, oops, sorry, the other bulbs will still light up. Yeah, okay, because the current is still on, right? Then of course the third one is each bulb, I explained many times, each bulb can be individually turned on and off, and right, turn on and off, okay, without affecting the other bulbs, right? Without affecting the other bulbs. Okay, so these are the 3 possible answers, right? So I explained to you again, this bulb 3 units. So I'm gonna show it to you again. So if this is 3 units, right, it's flying 3 units here, it is flying 3 units here, it's flying 3 units here. Alright, so this is the bulbs if it's in parallel. I'm gonna ignore, not gonna leave it there. But here you use it in series, then you have 3 units here. Okay, but here you have 1 unit because it's sharing the path, the circuit with 1 unit and 1 unit. So as you can see, there's only 3 units of brightness total here, whereas there's 9 units of brightness of total just now. Alright, so that is why it is brighter here. Alright, second one is if one bulb fuses. So imagine if this bulb fuses. Now remember, if the bulb fuses, it immediately becomes an open circuit. So if this bulb here fuses, the second and third bulb can still light up. Whereas for over here, if the bulb fuses, alright, the rest cannot work. Alright, so that is the reason why this uh, parallel is a better arrangement for this purpose compared to this. Alright, then Mr. Zaki, why do we have series at all in the first place? Actually, there is some use for there is a lot of uses actually for series arrangement, but in so actually series arrangement is also good but not for this purpose of making bulbs in your house, right? Or arranging the lighting arrangement in your house. Okay, because in your for this purpose, parallel is definitely better. Whereas series might have its uses elsewhere, but not in arranging the lighting in your house. Okay, so I hope you have learned from this. I'm trying not to keep the video for too long. Okay, so if you don't understand, just replay the video again. Again, I like to say the noise, background noise is the internal fan of my computer. I really have no control over it. It is the best that I can do for this weekend. All right. Okay, so thank you very much. Please understand this. Of course, the best way to know this is to go to the simulator website I told you about and try to draw this inside the simulator. Then you can see the electrons moving. Then you can understand. Play with the switches, play with series arrangement and parallel arrangement, right? If you really want to learn electrical components, electrical circuit arrangement and design, please go to the simulator and practice from there. Thank you.